17 is on something called implicit differentiation. So the last method that we learned was the chain rule. This is very, very similar to the chain rule. Basically the reason that we have the chain rule is because of this implicit differentiation and vice versa. So like, you guys remember how we took the derivative of something that looked like f of x squared, right? We took the derivative by doing 2 times f of x to the first, and then we multiplied by f prime of x, right? This is what implicit differentiation is. So whenever you have a y term, which is what f of x is, we always multiply by the derivative of y, okay? So it says sometimes we have equations that cannot be solved for one variable. So for instance, the equation of the circle centered at 0, 0 with radius of 5. You could try to solve for y, but if you do, you get y equals positive square root of 25 minus x squared. And you also get y equals negative square root of 25 minus x squared. So if you guys have ever tried to graph a circle on a graphing calculator, I'm sure that you've done this. You have the first part if you just, like the top part, if you just leave off the plus or minus. So that's why we need the negative part as well, because then it graphs the second part in. Okay, so it's not a function, so it would be 2 functions put together in order to make that circle. So there are many equations like this. So the folium of Descartes is shown. It's kind of a little loop-de-loo there. And it's defined by the equation x cubed plus y cubed equals 3xy. So it's not a function. It doesn't pass the vertical line test, right? But we are not able to solve for y. Okay, so how do we find a derivative? Like, how can I find the tangent line at, this point right here? How do I do that? I want to know how to be able to find the slope. Okay, so we use something called implicit differentiation. So it says in order to do this, we differentiate both sides of the equation with respect to x and then solve for y prime, which is really dy over dx. Okay, so let's try it with the easy example first. So if I have x squared plus y squared equals 25, it says go ahead and find dy over dx. So find y prime, right? So what we're going to do is we're going to take the derivative of x, or x squared, I guess, and we're going to get 2x. But then we're going to take the derivative of y squared, and we're going to have 2y, and we're going to multiply by dy over dx. Okay, does everybody understand? It's just like the chain rule. Like if you had f of x, you need f prime of x. All right, and then the derivative of 25 is going to be 0. All right, we did not put a dx over dx here. Oops, dx over dx. Yeah, because it's just like units. If you had meters per meters, we don't write meters per meters. We just leave it off. Okay, does it make sense?
Why would you not dx over dx is x prime?
No, there's nothing. It's just 1, basically.
Why?
So dy over dx, what that stands for is the derivative of y in terms of x. That's our f prime. Okay, just like what I was talking about earlier, if you had f of x squared, that's what we have, right? Y squared, its derivative is going to be 2 times the y value, f of x, times y prime. Okay, it's exactly the same thing as the chain rule. Do you guys understand? All right, so the rule for implicit differentiation is anytime we take the derivative of something with x, we don't tack anything onto the end. It's just like normal. But anytime we take the derivative of something with a y, we tack on a dy over dx, okay? So when we solve, we're going to get the dy over dx by itself, so I subtract the 2x over. I divide by my 2y. So I get negative 2x over 2y, which is negative x over y. And that is your derivative. So you can leave it with a y in it. So could we have done this, another way? Could we have solved for y? Sure. So if you had solved for y, then we'd have our y equals plus or minus the square root of 25 minus x squared. We would have, subtracted the x squared over, taken the square root. You guys see that? And we could treat that like the chain rule. We could say, oh, well, that's 25 minus x squared. Oops, x squared to the 1/2. So when we take the derivative, we'd get plus or minus, we'd have 1/2, 25 minus x squared to the negative 1/2 times negative 2x. So we'd have plus or minus, we'd have that 1/2 times negative 2, so it'd be like a negative x all over the square root of 25 minus x squared. So when we have a plus or minus and a negative x, it's kind of redundant. Like there's too many signs. Like if I have the opposite of a plus or minus, we sometimes write it as minus plus. Have you guys ever seen that in math books before? You're like, I never look at math books. You should. Remember I told you you could get a math book? All right, so a lot of times we'll write it as minus plus, but it's the same thing, plus or minus. All right, so the question is this the same? It doesn't look the same, does it? These two things, they don't look the same. But are they? Yeah, because the square root of 25 minus x squared with the plus or minus, isn't that just y? Do you guys see it? We solved for y. Wasn't that the same as plus or minus the square root of 25 minus x squared? So our answers are identical. Okay, so one of them has a y left in it and one of them doesn't. So we are allowed to leave the y in the final answer. Yes?
Is there any difference why that one's negative and the other one is plus or minus?
Okay, so let's think about that. So I think it will make sense when you think about the particular points. So let's look at the next thing. So it says find the equation of the tangent to the circle at the point 4, 3. All right, so actually, Will, answering your question, let's just do this. Do you remember how it was a plus or minus here? So plus or minus out front. And then it was a negative. So it is exactly the same because this was plus or minus. So they're identical. But when you're choosing which one, you have to think about the point that you're at. Okay, so we want to find the slope. So our m value was that dy over dx. And we're evaluating at the point 4, 3. Sometimes we write this kind of fancy, and we do like 4, 3 like that. That means plug in 4, 3 into the dy over dx. All right, so looking at our slope, dy over dx, it was just negative x over y. So I'm going to have negative x over y, so negative 4/3. That's my slope. So then it's finding the equation. It's going to be y minus 3 equals negative 4/3 times x minus 4, like that. So if you had used the other version, you would have to make a decision on whether that was plus or minus. So you would plug in your 4 for x, and you would get 4 over the square root of 16. Is that right? 16? No, 4 over the square root of 9, which is 4/3 still. But you have plus or minus. So that's when you would kind of have to look at your graph and make a decision. So if we had that graph with a radius of 5 at 4, 3, it's right there. Would the slope be positive or negative? It would be negative, so you'd have to make a choice. Okay, so see how the implicit differentiation is kind of easier because it has the signs for us already.
So easy. Why didn't you just do this before?
Oh, you like the implicit differentiation? I think it's harder. This is the first example, right? Ian's pumped. He's like, oh, this is easy, but it's not always easy. All right, so number 2. So it says find dy over dx at the specified point, and then write the equation of the tangent line at that point. Okay, so we're going to take the derivative of this equation. Anytime we take the derivative of a y term, what do we tack on? So this part we have x, y. So we're going to treat it as the product rule, x times y, right? So I'm going to have first is x, derivative of y is going to be 1, but then dy over dx, right? So I'm just going to write dy over dx, plus the derivative of x is 1, and then y just how it is. Why did I not tack on a dy over dx on that part? I didn't take the derivative of y, right? I just left y how it was. 2y, I don't know. Well, we're not done with that. Then we have the next part, yeah. So then plus, so the derivative of y squared is 2y. It was a y term, so I do dy over dx, just like it was an f of x, right? F of x squared is 2, f of x, f prime of x. And then equals 0. Like that. Well, what's the derivative of 4? 0. So you take the derivative of everything. All right, you can simplify it a little bit if you want by distributing that negative in. So we get 3x squared minus x dy over dx plus, or no, wait, minus y, right, if I distribute the negative. So minus y plus 2y dy over dx. And you could solve for dy over dx. You can get the dy over dx by itself. Okay, so I'll show you how to do that, and then I'll talk about we don't have to do that. So if I was getting dy over dx by itself, I would leave everything that has a dy over dx term on the left side, and I'd take everything else on the other side. So we're going to leave the dy over dx terms. So I'd have 3, well, no, that's going to go to the other side. So I'm going to have negative x dy over dx plus 2y dy over dx. And then I'm subtracting my 3x squared over, and I'm adding my y over. Do you see what my next step would be now?
Divide by negative x and by 2y.
Okay, so just divide by negative x and then divide by 2y.
Yeah, pull out the dy.
Yeah, pull out the dy over dx, because then in parentheses you'd have negative x plus 2y. And then you're going to divide that whole term over. So you're going to have dy over dx equals negative 3x squared plus y all over negative x plus 2y, like that. So you could solve for dy over dx. But what I always tell my students is that doing this, too much work. We don't need to do that because we were given a point. So it said find the equation of the tangent line at 0, negative 2. So that's too much work. If you have a point, just plug it in. So we're going to plug in 0 for x and negative 2 for y. So I'm going to have 0 minus 0 dy over dx, which is still just 0, minus a negative 2 plus 0 dy over dx. Oh, no, not 0. Hang on, that was 2y, wasn't it? So minus 4 dy over dx equals 0. So I have 0 equals 2 minus 4 dy over dx. And we can solve for dy over dx, right? So I'm going to add that chunk over. So I have 4 dy over dx equals 2. So I get the slope dy over dx equals 2 over 4, which is 1/2. So we know once we have the slope, then we can write the equation of the tangent line. So our equation of the tangent line is y minus y1 equals m times x minus x1, right? I didn't have to write point slope form because it was actually the point 0 comma something. So I knew that that was my y-intercept. So negative 2 is my y-intercept. So I could have just written it as y equals mx plus b. Are you with me so far? All right, so let's try another one. So if we have the point, don't do all that work to solve for dy over dx. Sometimes you have to. Sometimes you don't have a point and it just says find the derivative, find dy over dx, right? And then you have to do all that. All right, so this first one. So I'm going to go ahead and find the derivative. Do you guys see that there's going to be product rule involved? Yeah, so if you want to circle, like you have x squared and you have y, and then you have x and you have y squared, right? So we're going to do the product rule for the first one. So I'm going to have first is x squared times the derivative of y is dy over dx. Plus derivative of the first is 2x, and then y just as it is, just y. So that was the first product rule. And then I'm going to have minus, and then I'm going to do the second product rule. So I have first times derivative of the second. So what's the derivative of y squared?
2y.
2y. Oh, you've already forgot. dy over dx. Because it was a y term, right?
You still need the 2y and the dy dx.
Yeah, the derivative of y squared is 2y dy over dx. Yep.
And this just with y, it is just dy over dx. Yeah,
Because it was 1 dy
yeah.
over dx, yeah. Okay, so then I have plus, the derivative of x is 1, and then y squared just how it is. Equals 0, right? Derivative of negative 6. Don't forget to take the derivative. A lot of people will forget the derivative of the number. So you can clean it up a little bit. So we have x squared dy over dx plus 2xy minus 2xy dy over dx minus y squared equals 0. So I just distributed the negative end. And you can solve for dy over dx, but you probably don't want to, especially on your homework, because I have several where there's points. Just plug the points in, right? So we plug our point in. So 2, negative 1. So 2 for x. Negative 1 for y. Oops. So you should get 4 dy over dx minus 4 plus 4 dy over dx minus 1 equals 0. Do you guys all have that? Don't just copy what I'm writing. Try to do the problem. We're going to subtract our numbers or add the numbers over. So I have -4, so I'm going to add it to the other side as 4. I'm going to add the 1 over, so I get 5. And when I combine my 4 and my 4, I get a total of 8 dy over dx. So I get dy over dx equals 5/8. Did you guys all get that?
Wait, isn't it a -1? So isn't it like a +1 there? Because
Nope, because -1 squared is 1, and then you still have that minus out front.
isn't it the... Oh,
Did you distribute your negative?
I'm tired. That test.
So it's going to be y minus a -1, so +1 equals 5/8 times x minus 2. Is that correct? Did I make a mistake? You guys are discussing. It's making me nervous. I'm good? All right. All right, now if you get bored, like not bored, but if you are too lazy to write dy over dx, you could also write y prime. But I just caution against that because a lot of people will lose that prime. They'll just think it's y to the first, or they'll leave it off, okay? So be careful if you write y prime. All right, so this one actually says find dy over dx. There is no point here, right? So that means that we have to solve for dy over dx. Okay, so this first one, I'm going to have 3x squared. I don't need a dx over dx. Plus 3y squared times dy over dx equals 0. Make sure you have 0. Derivative of 1 is 0. We subtract the 3x squared over. You guys see we're going to divide by the 3y squared. We divide by 3y squared. And we're left with our derivative of y in terms of x, which reduces down to -x squared over y squared. You may leave your answer like that. Will the AP test do weird things sometimes?
Yes.
Sure. Multiple choice can be difficult on the AP test. Maybe they solve for y and they say, oh, y cubed is 1 minus x cubed, which means that y is the cube root of 1 minus x cubed. And then they plug it in and they say we have -x squared over 1 minus x cubed under a cube root, but then squared, so raise the 2/3. Could they do that? Sure. Why they do that, I don't know, because the whole point of implicit differentiation is that you don't have to solve for y, so why do they make you solve for y, right?
So if you don't see what your answer are, should you like plug in y and see what happens?
Yeah, if you don't find your answer, then you can kind of play around with it and try some different points and so on, but yeah, it's tricky.
That's just annoying.
All right, so this next one, so sine of y equals x. So if I take the derivative of sine of y, what do I get?
Cosine of y.
Yeah, cosine of y times dy over dx, because it was a y term. And the derivative of x,
Is the dy over dx in the cosine or is it outside?
it's outside. It's like the chain rule, it's tacked on to the end. So equals 1. So do I leave it like that? I do dy over dx equals 1 over cosine of y, which could be written as secant of y, exactly.
Would we have to write a secant of y, or is
I would guess that if it was a multiple choice section, it would leave it as secant of y. All right, still good with these? All right, occasionally you have something really weird where you have like a chain rule kind of thing going on. So let's do this one. So it says cosine of 1 plus y. So its derivative is going to be negative sine of 1 plus y times the derivative of the inside, right? The derivative of 1 plus y. What is the derivative of 1 plus y? dy over dx. It's like 0 plus dy over dx, right? Equals sine of x, its derivative is cosine of x, and then the derivative of 5? 0, right? So if we're solving for dy over dx, we're just going to divide that over. So I'm going to have cosine of x over negative sine of 1 plus y. There is nothing you can do here. You cannot write cotangent. Why can I not write cotangent in this
because
example?
they are the negative
Yeah, those arguments, the thing you're taking the sine or cosine of, are not the same thing, right? They're different angles, so you can't say cotangent. So you can put the negative on the bottom, or you can put the negative on the top. I usually put the negative on the top. But. All right, so let me give you another example here. Do you have enough room? Maybe. All right, so this is example D. So what if I had cosine of x plus y equals, I don't know, 5x squared minus 4x. Well, we'll do 4y. Let's say we have that. Okay, occasionally there are really weird ones. You might have one of these on your homework, so this is why I kind of wanted to do it. So cosine of x plus y equals 5x squared minus 4y. So if we take the derivative, it's going to be negative sine of x plus y. But then the chain is now what? 1 plus
dy
dy over dx equals the derivative of 5x squared is 10x, and the derivative of 4y is 4 dy over dx. Okay, when you're solving for dy over dx, it's actually kind of tricky. Do you guys see it? Kind of think about how you would solve for dy over dx. It's hard because I have a dy over dx on both sides, so I know I want to get them on one side. But then the dy over dx is kind of inside that parenthesis being multiplied by negative sine of x plus y. So does anybody have any ideas on how we would solve for that?
Should you distribute it?
You should. Yeah, you should distribute the negative sign.
That was really helpful.
So you're distributing it in. So when we do that, we get negative sine of x plus y. And then we have minus sine of x plus y times the dy over dx. And then that's all equal to the 10x minus 4 dy over dx. Now you can get the dy over dx's together. So let's say I'll get them on the left-hand side, or on the right-hand side. So let's say I subtract my 10x over, and then I add the sine of x plus y dy over dx minus 4 dy over dx. Then I can pull out that dy over dx. And then I'd have everything in parentheses, right? And then I would divide it over. So your final answer is going to be negative sine of x plus y minus 10x all over sine of x plus y minus 4. And you cannot reduce it down anymore. You can't like clear the signs because the sum on the fraction, right? Sum or difference. That's how you do it. So they can be weird. All right, so the next one. So number 4 is a little bit different. It says find y double prime. All right, so that's the second derivative. Sometimes you might see this written as, it's a weird notation. It looks like d2y over dx squared. So the 2 on the top signifies the second derivative, right? d2, second derivative. And then the x squared on the bottom signifies the units. So basically, if you have like the second derivative, like think about velocity and acceleration. If velocity is in feet per second, what is acceleration in? Feet per second squared. Does that make sense? So it's saying the bottom becomes the squared, whatever you had for the first derivative. So it's kind of a weird notation, but anytime you see that, it just means the second derivative. It's the same as y prime, or y double prime, I mean. Okay, so we take the derivative. So I'm going to have 4x cubed plus 4y cubed times dy over dx equals 0. And I'm able to solve for my dy over dx. I'm going to subtract my 4x cubed over, and then I'm going to divide by my 4y cubed to leave me with just dy over dx. And I can simplify to negative x cubed over y cubed. So that's the first derivative. That's the same as y prime, right? So how do I find y double prime? Yeah.
The derivative of dy over dx.
Yeah, the derivative.
dy over dx squared.
So we find the second derivative. So I know you guys probably don't like that notation. I never liked it in school either. If you just want to write y double prime, it's the same thing. So I have a quotient. So I have to do the quotient rule, right? So I'm going to do low is y cubed. D high, so the derivative of negative x cubed is negative 3x squared. Minus high is negative x cubed. D low, what do I write for D low?
3y squared dy over dx.
3y squared times dy over dx. All over the square of what's below. Y cubed squared is y to the 6th. But it's weird because I have a dy over dx in there. Seems strange, right? The answers will never have dy over dx in there. What do you think that they do? Replace it with what?
With
Yeah, we're going to replace it with that negative x cubed over y cubed. All right, so we're going to continue. So we have negative 3x squared y cubed plus 3x cubed y squared times the thing that it was equal to. dy over dx was negative x cubed over y cubed, all over y to the 6th. And it looks a little messy. So we get negative 3x squared y cubed minus 3, how many x's do I have?
X to the 6.
How about the y's? 1 on the bottom, right? All over y to the 6th. And do you think they're going to leave it as a fraction within a fraction? No. So do you guys know how to finish this off? There's one last step.
Common denominators?
You could get common denominators, and then you could divide by the y to the 6th. The easiest thing to do, this is Maury's favorite trick. He's always doing this. We multiply by y over y. So the whole numerator by y, the whole denominator by y. It doesn't change our fraction because we've multiplied it on the top and the bottom. It's just like we did these in algebra too as well. Like if I had something like this, you're able to actually multiply by 8 on top and 8 on the bottom because you're not changing the fraction.
So
Okay.
negative 3x squared y to the 4th.
Yep.
3x to the 6th over
So you get negative 3x squared y to the 4th minus 3x to the 6th, the y's would cancel, all over y to the 7th. Ooh. Do you guys still like implicit differentiation? It's okay. It does get hard. There are some hard questions. All right, is that the last one?
Under oath when I
All right,
said
one
I
more.
liked it.
I know, it's terrible. All right, last question. So it says, find the points at which the graph has a vertical or horizontal tangent line. Okay, so you can't solve for y. We have y squared and we have y. So we are going to go ahead and take the derivative, and whenever we see horizontal tangent lines, do you guys remember, well, vertical or horizontal. So let's start with horizontal. What does that mean?
Equals 0.
Yeah, we want our slope equal to 0. What if it says vertical? Yeah, so we want the whole slope to be undefined, right? So set the denominator equal to 0. So we're going to take the derivative. So I'm going to have 8x plus 2y dy over dx minus 8 plus 4 dy over dx equals 0. Because the derivative of 4 goes away. I get anything that doesn't have a dy over dx over to the other side. So I'm going to subtract my 8x, and I'm going to add my 8 over. When I do that, I'm going to have 2y dy over dx plus 4 dy over dx. Can you guys kind of pull out the dy over dx as you're doing this? If you can't, well, I'll write it on the notes. So you can pull out the dy over dx as you rewrite if you want to. So we end up getting dy over dx times 2y minus, or 4, 2y plus 4 equals negative 8x plus 8. So dy over dx equals negative 8x plus 8 all over 2y plus 4. Do you notice anything about all of them?
Oh, divisible by 2.
They're all divisible by 2, so we could really write negative 4x plus 4 all over y plus 2. And in general, if there's like a lot of negatives, then your multiple choice would just like multiply by negative 1 on the top and the bottom. So like sometimes you'll get answers that look like this. Like something like that. And instead they'll multiply by negative 1 over negative 1 just to make it a little bit nicer.
3y minus 7
Yeah, 3y plus 7. All right, so anyway, so we have that. So we're trying to figure out when our slope equals 0 and when our slope is undefined. So our slope equals 0 when our numerator is equal to 0. So negative 4x plus 4 equals 0. So that's at x equals 1. And then our slope is undefined when y plus 2 equals 0. So y equals negative 2. But be careful, the question says find the points. So we have x equals 1. These are always hard. How do I find the y value that goes with it? I go all the way back to the beginning, to the original equation, and I plug in x equals 1. So when you plug in x equals 1, you get 4 plus y squared minus 8 plus 4y plus 4 equals 0. You guys see that? I plugged in x equals 1 for all of the x's.
So it's y squared plus 4y equals 0.
So it's y squared plus 4y equals 0. The 4 minus 8 plus 4 goes away. And we are able to solve that. We pull out a GCF, which is y. So we get y equals 0, and we get y equals 4. Okay.
4y equals
Negative 4, thank you. Dang it. It's already moving on to the next part. All right, so what are our points for that one? 1, 0, and 1, -4. Those are the points that make your horizontal tangent line. So you have a horizontal tangent line at those points.
What about
So what about the y equals -2? So we go back to the original, and we plug in y equals -2. So we get 4x squared plus 4, right? -2 squared is 4, minus 8x minus 8, 4 times -2, plus 4 equals 0. The numbers go away on this one too. That's kind of nice. If they didn't, you'd have to factor, right? So we get 4x squared minus 8x equals 0. Again, pull out the GCF, which is 4x. We're left with x minus 2. So we get x equals 0, and we get x equals 2. So our answers are 0, -2. Oh, I think I'm good. 0, -2, and 2, -2. So we have the y value is -2, right, from here. So we're plugging in for y.
how you were doing?
Yeah.
My bad.
All right, does that make sense? So that's the place where you have a vertical tangent line.
Do I hit on?
All right, that's it. Yeah, you do. All right, we'll stop there.